Okay, so ladies and gentlemen, what we're looking at doing here. Is that right? Alright, so I need to cover this information, guys, because we're going to cover two different functions now. The nice thing about operations of functions, this is something you guys have actually done in Algebra 1. This is something you've actually done already in Algebra 2. And we're going to do it one more time as far as applying the operations. The only kind of difference is we are going to start investigating a little bit more complex functions, and we are going to be finding the domain after we have applied our operation. Okay? So I'm just going to focus on a couple of operations. We're going to kind of keep this simple, and I'll try to expand you guys to looking at different functions and how that develops our domain. So first of all, in each of the problems that we're going to have, we're going to be given some different functions. 1 over x plus 1 and g of x equals 1 over 2x plus 1. Okay? And what we're going to kind of practice is, again, kind of looking into what we can do with these two functions. Well, one of the main important things we can do with these two functions is add, subtract, multiply, and divide. And that's exactly what we're going to do with everything. Now, for the purpose of the instruction, you guys are going to be doing a lot of work today, so I don't want to be spending a whole bunch of time doing examples. But I am going to kind of work through a couple of examples. So one thing you guys might see is notation looking like this. F minus g of x. And basically what that's asking us to do is to take the f of x function and subtract it from the g of x function. Okay? So when we're doing that, all we're simply going to do is take the rule of each function and subtract them. Now, I chose this because I know even though you guys went through this in Algebra 1, many of you probably have forgotten the operations of adding and subtracting rational expressions. So I want to make sure we kind of review that. So remember, guys, fractions a lot of times have bad connotation, but remember the days when fractions were good. The days when fractions were good were days like this: 1/3 plus 1/3. Right? Kind of like remember those days, and we kind of like that. That equaled just 2/3. That wasn't that bad, right? You guys kind of remember, oh, all right, I kind of enjoyed those days. Like, I can do that now. That's not that bad. The times when fractions got a little difficult, or not so much fun, is when we started introducing different denominators, right? And if you guys remember, whenever you're adding or subtracting, you have to have common denominators. So what we would do is we'd say, all right, well, what is the common denominator? What's the smallest number that 4 and 3 both divide into? 12, right? And one way we first learned how to do that would be to listing the multiples. 4, 8, 12, 16, 3, 6, 9, 12. Oh, okay. That is a number that they both divide into. So if I need to get 4 to be 12, I need to multiply by 3. I have to make sure I multiply 3 on the top and the bottom. And over here, 4 on the top and the bottom. All right? So once I go ahead and do that, I'm going to erase this now. I now would obtain 3 over 12 plus 4 over 12, which equals 7 over 12. So it wasn't that fun, but it just required a little bit more work, but this was all work that you guys have already done way back in the day, right? All right, so fractions starts getting a little bit more confusing once we introduce variables. So once we start doing with x's, we had to think about what are the multiples of x. Well, this isn't as bad, especially when you're paying attention and not talking to your neighbor. It's x, x squared, x cubed, x to the 4th. So we could actually, x's actually aren't that bad. Where it gets really confusing is once we have expressions. How do you find the LCD of the expression? Like, what are the multiples of 2x plus 1? Don't even have to think about it or bring out a number. You guys can automatically, your brain kind of like stop. Like, oh, I know 4 is 4, 8, 12, 16. I know x is x, x squared, x cubed, x 4th. 2x plus 1 with like 4x, like, don't even have to think about it. So let's think about what is the easy way to find the LCD. We listed out the multiples long ago to find the LCD here, right? Or what else could we have also done to find the LCD? A really easy way would just be just to multiply them, right? Just multiply the two denominators, and that gives you a common denominator. It doesn't always give you the least common denominator, right? Because if 6 and 2 are your two denominators, 12 is not the least common denominator, but 6 is. So it doesn't always work for numbers, but when we're dealing with expressions, it is going to work that way, usually. I mean, case by case, really. So if I want to find the LCD, though, the easiest thing I need to do is just multiply my two denominators. I don't need to think about the factors or any kind of crazy stuff. Just multiply them. Okay? So if I need this denominator to be x plus 1, 2x plus 1, what do I need to multiply x plus 1 by? What should I multiply this by to obtain this? 2x plus 1. And you multiply it on the top and the bottom. Over here, I need to multiply by x plus 1 on the top and bottom. Okay? When doing that, I now obtain, I'm going to erase this because I don't want you guys to get confused. That's okay. I mean, it's just review work. Now, I know these denominators look a lot more confusing than 12, but are they exactly the same? Yes, they're exactly the same. So what happens? What did we do with our numbers? When the denominators were exactly the same, we applied the operation to the numerator, right? The denominator stays the same. You apply the operation to the numerator. So guys, all we have to do is combine the denominators, so it's the same, and then just apply the operation. Now, please remember that this negative, you're subtracting x plus 1, not just x. So you got to make sure you distribute that negative sign. So in reality, what we have is 2x plus 1 minus x minus 1 all over 2x plus 1 times x plus 1. We can simplify that one more step further. 2x minus x is just going to be x. 1 minus 1 is 0. So therefore, it's 2x plus 1 times x plus 1. Okay, and voila, we're done. You could multiply this out, but the next step we're going to do is find the domain. Now, when we're finding the domain, we actually want it in factored form, right? Remember your homework example? Remember when it was in factored form? I didn't have to do anything. All I had to do was, if I want to find what values are not a part of this domain, I know that the values of x that make the denominator 0 are not in the domain. So all I'm simply going to do, find my domain, is set 2x plus 1 times x plus 1 equal to 0, or at least not equal to 0, because those are the values. Yes? Looking for something good? So now, when I set them both equal to 0, I say x cannot equal negative 1/2, and x cannot equal negative 1. To speed this up, I'm just skipping some of the algebra steps for you guys, if that's okay. I just set each one equal to 0 and solve. So now, to write my domain, I'm going to go, it's all real numbers except for negative 2, negative 1/2, except for negative 1. So it's going to look like this, negative infinity to negative 1, union, negative 1 to negative 1/2, union, negative 1/2 to infinity. Right? Yeah. I've done this over and over, so that's why I'm kind of moving a little bit quicker for you guys. Alright, so that's subtraction. Addition works the same way. Alright. Multiplication works very similar to division, but I'm just going to focus on division for this case because we'll cover multiplication when we do division. So let's go and look at a division problem. Let's look at f divided by g of x. Now, when we're looking at f divided by g of x, that's going to look something like this. F of x divided by g of x. You guys can see either notation. That's why I want you guys to be comfortable with either notation. Are we good with this work? I know it's like a lot, but can I erase it or is it somewhere? Alright, so adding, subtracting fractions stink because you have to get that common denominator. But hopefully you guys understand that the quick and easy way to find the common denominator is just multiply your two denominators and then you automatically got a common denominator. Division though looks a lot crazier than it really is. So if I'm going to take my f of x, which is, let's actually do this down here, 1 over x plus 1, divided by g of x, which is 1 over 2x plus 1. So we have a fraction in the numerator and a fraction in the denominator. Ladies and gentlemen, if we want to simplify this, we want to get it down to just one fraction. One numerator, one denominator. That's at least easy enough, correct? So we want to get rid of one of the fractions. And typically, what's nice, it's easiest to get rid of is our fraction that's in our denominator. So how do you get rid of something? Well, let's think about, we're not really getting rid of it. You just can't like erase it and say, hey, it never happened, it didn't occur. But what we can do is use mathematical properties. Does anybody remember if you have a number like 1/4? What happens when you multiply 1/4 by its reciprocal 4 over 1? It equals 1. Anything multiplied by reciprocal equals 1, correct? What about anything divided by 1? 4 divided by 1 is? 4. So if we can turn this into 1, then we're just dividing by 1, which is kind of like, it's still there, but we actually kind of got rid of it in a sense. Does that kind of make sense?
No.
Twisted mind. All right, well, let's just work through it, and you'll see. So, let's get the denominator equal to 1. To do that, we multiply by the reciprocal. Whatever you do on the bottom, you have to do on the top. Does everybody at least see what I'm doing by multiplying by the reciprocal? Yes? No? Yeah? Maybe so?
Yeah.
Okay. Anything multiplied by its reciprocal multiplies to 1. So it's still there. It's just 1. Now, multiplying functions. If I would have given you guys the functions and then said, hey, multiply them. Numerator times numerator, denominator times denominator, right? So you just multiply straight across. So you obtain 2x plus 1 all over x plus 1. So guys, look what happened. Since we got this equal 1, we now have a fraction divided by 1. What was 4 divided by 1? 4. A fraction divided by 1 is just going to be that fraction, right? So we don't really need to include divided by 1. We can just write 2x plus 1 over x plus 1. Now I have something I can find the domain. Right? This is much easier now to find the domain. All the numbers that make the denominator equal to 0. Oh, that's kind of obvious. X cannot equal -1. So negative infinity to -1, union -1, 2. Gotcha?
What? Where did I lose you?
No, I looked down and then I looked back up and I saw it and I was like, hold on, what did you just do?
Yeah.
The x can't equal
Right. Because when you plug in -1 in for x, up here you get -2 plus 1, which is -1. Down here you get -1 plus 1, which is 0. And remember that any value that makes the denominator 0 is not in our domain. So it's all real numbers except for -1.
I got you. Okay. Thank you.
Yep. All right.